Hey folks, welcome back again to Advent of Code in F Sharp. We're at day 4. First 3 days were fun puzzles, so let's see if this trend continues. Ceres search. Looks like the sheaf's not here. Next. One of the historians pulls out the device and pushes the only button on it. After a brief flash, you recognize the interior of the Ceres monitoring station. That's a puzzle from 5 years ago. Wow. As the search for the sheaf continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with a word search, which is our input. They only have to find one word. Xmas. Word search allows words to be horizontal, vertical, diagonal, backwards, or even overlapping other words. What does that mean? Overlapping other words? No idea. It's a little unusual though, as you don't merely need to find one instance, you need to find all of the instances. Sure. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with dots. And the actual search will be full of letters instead, sure. In this word search, Xmas occurs 18 times, and that's all the instances where it occurs. Okay. Take a look at the word search. How many times does Xmas appear? That is a clear question. That is a big word puzzle as well. Whoa. Let's quickly grab that. Let's grab the example as well. Do we need a small one? I do not think so. We might start with the dots instead of the full puzzle, but we'll see. There we go, it's all loaded in. How shall we tackle today's problem? We just need to go over every letter in the grid and figure out whether or not there's an Xmas in any of the 1, 2, 3, 4, 5, 6, 7, 8 directions. Yeah? How would we go about doing that? That's a lot of index magic. Doing magic with indices, I think. Can we make it interesting? I don't think we have to make it interesting. Well, let's just solve this puzzle first. So, big outline. We're gonna loop over every position in this word puzzle. And we're gonna take a look at every of the 8 directions and see whether or not the 4 characters spell out Xmas. If they do, we have a hit, and otherwise we keep on going. So that sounds like looping over every... so that sounds like a double for loop. You can do the same in F Sharp with a for comprehension, so for row in... let's call the puzzle. Let's name a variable puzzle first, and that's just the example. I don't think we need to parse a list of characters is good enough. So we have a puzzle and we iterate over the puzzle for every row in the puzzle. Do something, and for every column in a row, do something, and let's just return row column. So this should be all the indices. I mean every element. We don't need the element, we need the index. Yeah, why am I looping over the rows and the columns? We need to have the indices. Oh, we've done this 20 times before. I'm sorry, looping over matrices and getting the indices. How do I typically do this? I don't care. Let's just do the simplest thing that could possibly work. Let's loop over. So let's take the length -1. Length is a function of the list module. There we go. And we need some extra parentheses here. Yeah, and for column in 0 dot puzzle, take the first element in this puzzle, get the length of that. And also -1. Ooh, I'm not fully awake yet. This is going very rusty. What's the problem here? Incomplete expression. Is the parentheses the problem? Apparently it is. Oh, it is not. We have strings. We have a list of strings. So a column is a string and not a list of something. But a string is secretly a sequence of characters. So if we use the sequence.length, that should work. There we go. I have no auto indentation anywhere, but or apparently Writer does something in the world of indenting. Okay, this looks correct. How many characters do we have? 1, 2, 3, 4, 5, 6, 7. How many characters do we have? 10. Yeah, that looks correct to me. So these are all the indexes, the starting indices. And so we're now looping over every index in the grid. That's great. And now we just have to find for every index in all 8 directions. What's the word? What's the 4-letter word there, if there is any? If we're like near a corner or near an edge, we won't even have to look for the word. How would we go about doing that? Can we use slices? Can we use slices? I think we can use slices actually. What's a slice? Let's start with what's a slice. I'm gonna parse the input a little bit or transform the input a little bit. I don't like that it's like a sequence within a list. So I'm gonna convert it to a list of characters quickly. So how do we do that? I'm just gonna do list.map of whatever we have, and that's the element inside this list is a string. So we're just gonna do sequence to list. Now we have lists of characters instead of a instead of a list of strings. So now everything is the same. We don't have to do any special things. But anyway, puzzle. Let's see what a slice does. So let's take the first. Will slicing work? Slicing will work if it's a 2D matrix, because we have to go up and down and diagonally. So let's make it a 2D matrix instead, our puzzle at least. What is a 2D matrix? Right now it's like implicitly a 2D matrix. It's a list of characters. But F# has support for 2D matrices. It's called Array2D. It's got support for 4-dimensional matrices, but we want to use a 2D one. So if you give a sequence of something to this constructor function, the Array2D function, it looks exactly the same, but it provides some additional functions that we can use. Yeah, I'm gonna generate the indexes based on... No, that's a bad idea. I'm gonna forget to replace it. I'm gonna call this raw puzzle. And let's call the actual puzzle the raw puzzle converted to an Array2D. And there we can efficiently index, or slice at least. So, back to the original point, what is a slice? If you take Array2D, or puzzle, and you look at the Array2D functions, 2D, oh god, 2D, this one, it has a lot of functions that can help us, but actually the slice I'm looking for is not a function in a module. It's a bit of a nicer syntax. It looks like you're accessing a list like this, but you can say, give me everything in the first row. So then you say something like this, it's the row 0 and column star wildcard, whatever, and then you get the first row. Should get the first row at least. If you say I want the first column, you can say give me everything in the row, but column 0. And then you get a vector containing every element in that first column. If we can do this backwards, and if we can do this diagonally, slicing will get us all the way there. So let's see if backwards works. What would backwards look like? First row, every element, but reverse. How would you go about explaining this to a computer or to the F# compiler? Can you do reverse slicing? I've looked this up 3 years in a row, I think, and I don't know if it's actually landed in the language. I'm merging this with issue. Okay, lots of discussions. Is this actually a language feature? That's the question we're trying to... It's in preview. It was in preview 5 years ago, but it's not ringing any bells, so I don't know what the current state is. No. Let's go to the original. Reverse. No, there's no hint of the word reverse in there. Let's play around with... Oh no, let's take a look at some examples. You can do this. End inclusive, empty slices. If this is a nice feature, this is also why I was also going for slices. If you're going like out of bounds, it gives you an empty slice, so we don't have to take out of bounds exceptions into account. We just have to work with the oops. We get an empty list instead. I don't actually know if that's a better feature than going out of bounds, but okay. You have to know about stuff like this. I don't see anything about reverse slicing. Let's see if we can figure this out. If you go from 9 to 7, will that work? No, because that's a... And if I say 9 to 7 but takes increments of -1, pretty sure we're able to do this on list slices. I'm pretty sure this was a feature. Let's do this on a list. Let's slice from 0 steps of 2 to 5. Incomplete expression or invalid use of indexer. I'm pretty sure you can do this. What's the correct syntax for defining a step size? Yeah, we're slicing multi-dimensional arrays. That's exactly what we're doing. It's cool if you have to grab like a sub two-dimensional matrix out of a matrix, which is not what we need. We just need vectors. I don't even know what to understand what's fixing an index and slicing other dimensions with that index fixed. Sorry. Okay, that's the start thing. Nope, I don't see stepwise. Maybe the thing I'm thinking about is not indexing or slicing, it's generating a list from 10 to -1. It's called a range, I guess. That works, yeah. That's not what we need. Can you not slice in reverse order? That's a shame. Okay, but we don't actually need it. If we can calculate like instead of going from a starting point and then going backwards, we can calculate the starting point and go forward. Because we know the word Xmas is 4 letters long, I think we might get there the hard way. Or even alternatively, forget about slices, just take a two-dimensional location, these indexes, and calculate all the possible locations where we have to look and just use those. Yeah, okay, we tried slicing and I got stuck on slicing or indexing in the negative direction. So let's leave that path for now. I'm pretty sure It's also doable, but let's leave that path for now. I don't think we even need to array2d them. Let's just generate all the indices and then just index into them. So for example, these are all the indices we could take a look at, and let's just loop over them, grab a single one, and then take a look at all 8 directions. So I'm just gonna grab a random one, 4, 0, no. What's the middle of the road? 4, 4, somewhat like this, something like that. So if we have a location like this, how do we generate all interesting locations? So in all 8 relevant directions. What would that look like? I'm gonna start by listing the offsets. So if we have a location like this, and for example, we want to see horizontally to the right, how do we find like the 4 locations that are relevant? It's the offset. If you look at like how much do we have to add to the row and the column index to get all those locations, it's the location itself. And then you have to go to the right, so that's increasing the column count by 1, by 2, and by 3. And if you take these deltas and apply them to, or you add them to the 4, 4, you get all the locations to get like the 4 locations reading from left to right horizontally. And if we do this, but in reverse, you get the locations right to left horizontally, and we can do the same for up, down, and diagonally. And I think that allows us to generate all interesting locations. I think so. So these are, let's call these offsets. And if we map something over the offsets, which is offset row, offset column, row, offset, column, offset. We just do the 4, 4, and we add that. Yeah, this will work. So let's call it location. Row of location, a column of location, and that's for example this 4, 4. And we do the row of location plus the row offset and the column of the location plus the column offset. That should give us everything. And instead of mapping, we do, oh yeah, it's a list of a list. It's a list of a list, so we have to iterate over every list. Oh, my brain is not awake. What are we trying to do here? We're doing the list map, but that's for a single list. We need to do that for a list of a list. There's a map missing here, right? There's a map missing here. I hope ReSharper will clean this up, or Writer will clean this up in a second. No, I thought it would be like, hey, you can get rid of stuff like this. Yeah, okay, so I think this is what I'm trying to achieve here. If you have 4, 4, you generate all the indices, that looks correct. These things can go out of bounds, right? They sure can. We're generating way too many indexes because a lot of these cases will fall outside of the word puzzle. Let's solve one problem at a time. Okay, so these are the horizontal directions. Vertically is the same, but we swap rows and columns. Oh, that was a copy paste too much. It's this we need. There we go. what's happening? Okay. All these parentheses and brackets, it's it's messing up my eyesight. Sorry. So let's do the column downward. And do the column upward. It's the same but different. I think I actually typed a semicolon and it disappeared, right? That's weird. Anyway, so this should be this one, and then we do the same with the diagonals. Those are 4 diagonals as well, right? What does the first diagonal look like? Why am I seeing squigglies? I don't understand what I'm doing consistently wrong here. Let's fall back a bit. I keep messing up my copy paste. Let's help resharper a bit by indenting it explicitly like this. Okay, now creating a new case should be easier. Yeah. Let's do this direction first. So that's going down to the right. What would upward to the right look like? That means decreasing the row indices. So that means doing this. Ooh, it's wildly inconsistent with the semicolons, so let's get rid of them. Yeah, so that's the diagonals to the right. Now the diagonals to the left, then columns have to decrease, but it's the same thing all over again, right? Columns have to decrease. Okay, there's probably lots of better ways to do this, but I think this might work. I hope this might work. This looks like a weird one, right? 536271. Is that correct? 445362. Yeah, that's correct. Okay. So I think this is a generator for all the offsets we need to, all the locations we need to investigate for a single element in the word list grid, the word puzzle. So if we loop over every location now, generate these 1, 2, 3, 4, 8 vectors, and then just take a look what's out there, and then take into account that we go out of bounds, we're there. Yes. I'm still convincing myself that this is a good plan, a good idea. So let's wrap this in a function. Called calculate offsets, and it just returns this entire thing. It's saying that, oh yeah, if I copy paste stuff, let's be damn sure it's the correct stuff. There we go. So how will we go about out of bounds? Do we just filter from this list of offsets? Do we just filter out the relevant rows? If there's one of these is out of bounds, we just ignore that one and we move on. That sounds pretty clean, right? If slices won't do it for us automatically, we'll do it by hand. So let's do calculate offsets. For the example we just took, and let's play around with it. So uh-oh. I don't know what I did, but something broke. My mouse scroll wheel doesn't work. My keyboard doesn't work. Oh, I landed in some kind of multi-select or multi-cursor land. I don't know how to fix this actually. I don't even know what button I pushed. What is this multi-cursor thing? And okay. No. This, okay, it looked like my tab key was stuck or something. Hardware issues yet again. Sorry for that. Okay, we're back. We're good to go. We have our offsets. Now, let's now filter this list of offsets. So we can, or I don't need to rename this. Offsets is available because it's like nested inside the function. That name is not taken yet. Let's filter out the useless ones. So a list of offsets, or a list of locations, sorry. So that's the locations, and every location in one of those rows has to be in bounds. In bounds of what? In bounds of the puzzle. Yeah, let's just use the raw puzzle. I don't think we need array2d for anything. And now we just need to define this inbounds thing. What's the dimensions of the puzzle? Let's grab the dimension of the puzzle. That's exactly this, right? 0 to this thing. Yeah. So number rows, that's this thing. Let's extract that into a variable. That can go, and this is the number of columns. Let's extract that into a value. And that's a weird place to define this variable, so let's lift it up a bit. Okay. Let's get rid of raw puzzle. We don't need that. Oh. Let's inline raw puzzle. Inline variable does not work. Writer, you disappoint me. Okay, okay. It's not the smoothest of sailing today, but we're still chugging along. So now we have rows and columns. We can do the inbounds thing easier. We don't need to pipe in the puzzle. We can just do num rows, num columns here. So row has to be positive, column has to be positive, and row has to be lower than number rows, and column has to be lower than number columns. Lower or equal in all the cases. Yeah, this should filter out some stuff. It should not filter off too much. Ooh, it filtered out a lot, actually. No, it's 8 rows. We're in the middle. Let's take 0, 0 and verify that our filtering and location calculation actually works. What do we expect if we're in the top left corner of our word grid? We can go to the right, we can do that diagonally downwards, and we go downward, right? This, yes. This, yes. This, yes. On first sight, I'm not exhaustively testing. This appears to do what I want. So this is actually what we want to do for every location, and then we just grab whatever is in the word puzzle, and if it's Xmas, we have a hit. Cool, cool, cool. What would we call this? So we calculate locations without looking at bounds. That looks cool for me. And then we filter out everything that is within bounds. So let's call this relevant locations, or relevant bars of letters that we need to take a look at. Let's call it relevant locations. All right, this inbounds thing. Yeah, let's keep it as is. So now let's loop over all the locations. This is called, let's call this let all locations. It's like a generator that generates all the relevant locations. It's a 1D array. We don't need to do, we just need to iterate over them. So that's cool. And now let's use all locations and map over them to generate all relevant locations. Yeah, we need to have an argument here instead of a hard-coded location. Yeah, that looks like it should do something. Okay, so now we're generating a whole lot of indices. And then for every relevant location, we just grab that array of locations, transform that or two lookups in the grid, and we should be done, right? So what is the type of this thing? A list of a list of a list of integers. We don't need to know anything about the structure or where it came from, so we're gonna flat map, we're gonna collect. And now we have a list of integers, and for every inner list of integers, that's like the 4 locations we have for a single possible hit. So now we can just use map. Have we used collect before? I don't know, but collect is like doing a list.map and the result of that thing returns a list. So you have a list of things, and collect just smooshes all those lists together. It concats all the lists. So now we have a list of possible 4 word locations. So we can just do list.map and look up every location. So we have locations. This should be a list of locations, right? Yeah. So we can do list.map lookup in the puzzle. And lookup does not exist yet, so let's create lookup. Lookup puzzle row and column equals puzzle row column. Is indexing something efficient? Yeah, it will be. Oh, I know there's a beautiful page that has like all the big O. Ah, there we go. All the big O things. So we're taking a look at indexing, element add, stuff like that. It will be like super fast, right? How is the simplest list method not in here? What would it be called? Find fold, no. No. It's not in there. Probably it's like 01 speedy. But I was curious. We won't, but we'll find out by how efficient this algorithm will run in just a second. It's given me an attitude. This expression was expected to have int list a, but here is type 2D. Where is 2D coming from? Did we not get rid of 2D? We did not get rid of 2D. I don't think we need it anymore, right? No, we don't. Okay, we're back to the list and the sequence thing. So let's do a list.map list to list sequence list of sequence. There we go. So that should... No, I thought actually that was a problem. It's a list of a list. Let's give this the type hint. So it's a character list. Really, that was a problem. We needed a type hint. Okay. Okay, this looks promising. So now we're mapping every 4 letter or 4 location things to what's in there. And if now we just need to like count the ones that spell Xmas, right? And if that's 18, we're good to go. List, filter. So the word should be X M A S. And we just need to count the number of hits. Not the most efficient way of doing things by far, but we get 18, which is exactly what we're looking for. Cool. I'm almost afraid to run this on on our input. So if the stream crashes right now, it's because I burned my CPU. But let's take a look at where or not it works. Let's make sure we get rid of example in all our code snippets. Yeah, okay. And let's replace it by input. How big is this grid of ours? 140 by 140. Slightly bigger, but not much bigger, right? So, yeah, let's just run the entire thing. Okay, that wasn't too bad. I was making the problem bigger than it was. That was okay. We don't need to optimize anything. We can move ahead. And it's even correct. Good job, us. I'm actually proud of myself. It was a struggle, but we struggled through the wall. Okay, let's take a quick peek at part 2. Part 2. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It's an X-mass puzzle in which you're supposed to find 2 mass. Oh no, 2 mass in the shape of an X. It's a Crossmas puzzle. Okay, one way to achieve it is like this. Irrelevant characters have been replaced. Here's the same example from before, but this time all of the cross masses have been kept. Oh, my brain. That's a bigger step than I was expecting. Okay, so we don't need to find like a single word. We need to find... But that's diagonal only, right? Or can we have Xmas in a... Is the X like the directions or not? Over here they're all like crosses. There's nowhere is there like MAS horizontally or vertically, right? It's always diagonally. That's actually not too bad, I guess. What changes? Not too much. Instead of 4 lengths, we do 3 lengths, and we have to find not 1 but cross, and only diagonally. That doesn't sound like too much of a change. So we just need diagonals. Let's get rid of this. It's gone. How are we gonna do this? And we need length of 3, so let's rip out this last thing. And then we just need the masses. And we need to do the extra thing being it has to be a cross of 2. So I think we can get started from here. Let's start from the example again. I think we can keep most of it. We can keep most of it, except let's not look for Xmas, but let's look for mass, and let's take it from there. So what does this look like? We're looking for all masses diagonally right now. And we have quite a few, but we kind of lost the original index, and that's not too good, right? Wow, we can actually do something similar. I think we're almost there. Famous last words. But instead of like, here we're generating like all the locations for one diagonal. But if we take like all locations for one diagonal and the other diagonal, and it's mass or mass Sam, I think we're good to go. Actually, if we just keep what's the middle? Would that be smarter? Now we're starting from like the leftmost letter, the M. What if we start from the A? Like the center of the cross? What if we start from the center of the cross? Yeah, it's not correct that we don't have to take a look at 4 things, right? We just need to take a look at diagonal 1, diagonal 2, and if we start from the center, it's just 5 locations. That'll be better. I'm convincing myself. I'm having an internal monologue right now. Should we be drawing stuff? Maybe we need to draw stuff before I rip out everything. So we have a grid. There's an A somewhere. What if we start from this? And we take a look at those locations. And an M has to be somewhere here, and an S has to be somewhere here, or flipped, and same thing here, or flipped. Oh, that's the worst S I've ever drawn in my life. So we loop over every location with an A, and we just take a look at the 4 diagonals in pairs, and if they are MS, we're good to go, right? That's simpler than what I was doing with my Xmas thing. Find all A's, look at diagonals. If it's MS, pairwise, we're good to go. Okay, that sounds simpler actually. So instead of looking at all locations, let's find all A locations. Ooh, I did something. All tests, I'm not running tests. Let's call this A locations. Let's filter. And let's grab our lookup function. We need that sooner now. And if we do a lookup of this location in Perl, and it's an A, we have a relevant location, right? What should that give us? 1, 2, 3, 4, 10-ish. Way more than 10, but 7 and 6, 5, 4. Yeah, that looks correct at first glance. So now we have all locations of A's. We can take a look at the diagonals, and we do the inbounds check. We can use largely the same approach, but not quite. So we have all A locations, cool. What do we need to do? As I always explain with my drawing at least, we need to look at diagonals pairwise, so top right, bottom left, and vice versa. And if those contain MS, we're good to go. So let's first generate those 2. So that's 1, -1, 1, That's like top left, bottom right. Now it's getting too hard for my brain. This is go left one, go up one, go right one, go down one. So now we need to do go left one, go up, down one, and go right one, go up one. Right? I think so. This is too important to get wrong. Wait a second. Go left one, go up one. Yeah. Go right one, go down one. Yeah. And then go left one, go down. And go up, go to the right. Yeah, that sounds correct. Now that I hear it a second time. Cool. And we do bounce filters. So let's see here. Let's grab everything and let's see where we are at right now. So we have locations of A's. And then we grab the pair ones. Actually, we can... Yeah, cool. And then we map those to lookups. And then we should take a look at... we don't need to flatten anymore, we just need to map, so that's the difference. We have to take the crosses into account and we don't have to squish everything. So now this logs thing is 2 lists of lists, and both have to be MS. Yeah. So let's take a look here. We have empty lists. We have empty lists in that case, and those are the ones we don't need to do anything for. We always need to... We always need 2 of these things to calculate a mass cross, right? So let's grab those. We only need the ones that are too long, where we have definite crosses inbounds. Yeah, and then for every potential cross, we do the lookups. So for every possible cross, we do both lookups. So let's just do a list.map a list of map dot list of map. That should give us a lot of M's and S's. Am I messing up parentheses? I am. So this should give me a list of MS's. And if both of these are MS or SM, is SM okay? Yeah, SM is okay. Then we're good, right? So so we're filtering again. And or we can filter in this horrible line above. No, let's do the filter as a separate step. Potential cross. And the diagonal should be MS or SM. And then we found all our cross masses. And let's count those. 9. So this was a very chaotic part 2, and I'm really not proud of the code I'm seeing here. This is super dense, super unreadable, but potentially correct. So let's just get it over with and see if it's correct. It's a number, but is it the correct number? It is the correct number. So I'm torn. I'm happy that we solved the puzzle, and I'm not so happy about the end result, actually. I think the approach is sound for both cases. Yeah, I'm happy with the approach. Doesn't look too complicated. I like that we switched gears for part 2, that we did the little drawing and the make it less complicated part. What I don't like, let's maybe take a quick look at part 1. I actually kind of like how part 1 ended up. It's a long pipeline of chaining together functions, but every step reads nicely. We just collect some locations, we do some lookups, we look at relevant hits, and we just count, so that's okay. It's here where this could use a second pass. This pipe is unreadably messy. Yeah. So maybe I might clean this up, but I won't do this right now. But this, I would not like this in my production code, for the reason of being too dense. So that's a challenge for me personally. I'm really curious about alternative approaches for today. If you did something wildly different, or if you figured out backward slicing, please let me know. I'm always interested in alternative F# solutions. So yeah, that was it. Day 4 in Advent of Code. We did it in F#, of course. It was a bit chaotic because I suck at counting indices or doing grid navigation, but we got there in the end. And I still haven't written that many tests. But if we don't need them for puzzles, I won't bother writing them. There's only so many hours in a day. Thanks for watching. Hope to see you again tomorrow. Bye bye.